Hello everybody, Root Beer here, hoping you're doing well and hoping you're ready to take another look at a Fryer contest. This time we're going to be looking at the 2013 Fryer contest. You can see right away if you open up a copy of the contest, and you'll find a copy in the link down provided with a link down below the video. You open up right away, there's sort of up in the corner, this 50 sort of grabs your eye. It's 50th anniversary of, I think, math contests, or perhaps just the Center of Education in Mathematics and Computing. So, with that sort of celebratory theme, how about we dive in and take a look at the paper? And once again, I will recommend that you do click the link in the description and you try to copy the contest ahead of time. So question number 1 of our 4 questions on the Fryer contest. Anne, Bill, and Kathy went bowling. In bowling, each score is a whole number. In Anne's first game, this is part A now, her score was 103. In her second game, her score was 117. What was her average score for these 2 games? Okay, averages aren't that hard to compute, so we can take a look at these. And average is just the total value, so the total number of points for Anne, divided by the number of games she played. Number of games. So what was her total value? Well, she got a 103 the first game, and 117 the second game, and she only played 2 games, I believe. 103, 117, average score for these 2 games. So we just add up the numbers in the numerator. We get 103 plus 117 divided by 2. We get 220 on the top divided by 2, 110. Alright, we'll put a little therefore statement. Again, we don't need to. We're writing out full solutions because you guys should really see how to write things for part marks. But if you'll notice, there's a little light bulb beside the A, which means we do just need the final answer. Okay, they mentioned that in the description up here. Always a good idea to read the tips and, of course, the full contest description. You don't want something to have changed from last year's contest and you don't know about it and you just don't get the marks. So, always a good idea to read through the whole thing. B part. In his first 2 games, Bill's scores were 108 and 125. His average score after 3 games was 115. What was his score in the third game? Okay, so there'll be a little bit of algebra here. We don't know his value, his score for the third game. So we can just give it a random number, let's call it x. And then we know how to compute the average, and we know what the average is. So if we rearrange that equation, we should be able to solve for x. And I'll show you what I mean. So let x be Bill's score in the third game. So his average is 115, but we also know that's the total number of points divided by number of games. 108 plus 125, and I will double check on these numbers to make sure I'm not doing it wrong. 108, 125. Yep, those were his first 2 game scores. And then x, his third game score. We don't know what x is, but we know it factors into the average. We know it's a part of the average. So 108 plus 125 plus x divided by 3 should give us our average of 115. So we bring the 3 over to the other side by multiplying through. 108 plus 125 plus x. Well, we can simplify some of these things. 3 times 115. That's 345 on this side. 108 plus 125. 233. And we have x all by himself. Now we'd like to get x alone on one side, let's say the right-hand side. So we bring this 233 over to the other side by subtracting. Whatever we do to one side, we have to do the other side, so we get rid of this 233, we're left with just x. And now we can simplify this. 112 equals x. So Bill's third score was 112. And if you wanted to, you could plug this back into our original formula just to make sure you didn't have any errors. So you could add 108 to it, and you can add 125 to it, and divide by 3. So 108 plus 125 plus 112. You can work that out on your calculator. Divide that by 3. We do indeed get 115. So this is the right answer. So we have one more part, and this is one of those written portion questions. It's not going to change how we approach it in this video, but it is something you need to keep your eye on, because to get full marks, you have to clearly explain what you're doing. Okay, after 3 games, Kathy's average score was 113. She scored the same in her 5th game as she did in her 4th game. Is it possible for her average score on these 5 games to be 120? Explain why or why not. Okay. So we don't have a lot of information to go on. In the previous 2 questions, we at least had some of their scores. All we have now is Kathy's average. We do know how many games she plays. She plays 3 games, gets an average of 113. Then she plays 2 more games, and gets the same score on each of them. So what we could do is we could give, just as we did in the last question with Bill, we said let x be the score in his 3rd game. We can give variable names to the scores that she got on her previous 3 games at the start, and actually her other 2 games. Alright, we can let A be her score in the 1st game, B be her score in the 2nd game, C be her score in the 3rd game, and so on. So what does the question tell us? Well, it tells us a couple things. We know that the average of her first 3 games, A plus B plus C, the sum of the first 3 scores divided by the total number of games played, 3. And we know that D is equal to E. So the last thing we were asked, is it possible, can we get 120 as the average of all her 5 scores? So A plus B plus C plus D plus E is the total number of points after 5 games, and we average that by dividing by the total number of games, 5. Okay. Well, we can rearrange this equation and say A plus B plus C is 3 times 113, and quick calculator work on that shows us that it's going to be 339. Okay, we know D equals E. So another thing we can do is we can say 120 is not A plus B plus C plus D plus E, but we can say plus 2 Ds. Okay. So here we're making the assumption that we can get 120 to be equal to the average of these 5 scores. Maybe it can't. Maybe it can't. And so How would we show that it can't? Well, if we set this 120 equal to the average of these scores, and we worked it through logically, we mathed it out at every single step, and then we got to a nonsense answer, like D being, I don't know, a third or something like that, something that it can't possibly be. Bowling scores are whole numbers, you see. So if we could get something like that, then we would know it wouldn't be true. If, on the other hand, we could find values of A, B, C, and D that do give us 120, then we'd be all set. So what we can do is we can rearrange this equation right here. A plus B plus C plus 2D is equal 5 times 120, which we can see is 600. So that gives us a nice linear equation, no fractions. This 5 down here, we got rid of it, just like we got rid of the 3 down here. And speaking of that equation, we know a formula for A plus B plus C, so we can substitute it in here. So 339 plus 2D is equal to 600. So it looks like we might be able to isolate for D. And if we got D being a whole number, maybe we could make up some values for A, B, and C, and we could get some scores and say, oh, yeah, Kathy could have gotten 120 as her average. Here's a possible way she could have scored to give that. On the other hand, some of you might be able to see a couple moves ahead and realize this isn't going to work because this will turn out to be an odd number, and this will turn out to be an even number no matter what D is. So 600 minus 339, 261. So then D is 261 divided by 2 equals So since D gives us a nonsense answer, and all we did was assume that we could get 120 as the average of those 5 scores, we know that that assumption must be wrong. I very much don't like writing on the next page because I try and start a fresh page each question, and it would be a bit of a waste. So, since D can't be a whole number, it isn't a score. It's not a bowling score. It's not going to work out. It's 261 divided by 2 is 130.5. Not a bowling score. And since we can't get D to be a proper score, our assumption must have failed us, and our assumption was that Kathy can get this average. So if that fails, then the opposite must be true, and Kathy can't get this average. So that concludes C part of this question. A nice quick introductory question involving averages, which almost everybody should have seen by grade 9. So it's a good question getting us started. We're feeling good. We're moving at a good pace. Hopefully you guys will join me in the next video for question number 2. I'll see you guys then.